I'm going to review the Python side of the exchange between the EEK and the DroneBlocks simulator. Again, some of the Python features here are maybe a little esoteric if you're a Python beginner. Most of what I'm using here I found in examples trying to make some of these features be easily accessible. And there is kind of some code here that's going to be used in the Crazy Fly, at least logically similar code is going to be used in the Crazy Fly Python in the next lesson. So you have to be naming in your Python where the Python code runs. I wish it was a little bit less, you wouldn't have to bury the actual numeric IP address in the Python, but this seems to be the most reliable way to get the code to kind of consistently behave. And then the main method here is called move with controller. And our default distance movements are going to be in 40 centimeter increments. And then this style of with DroneBlocks Simulator Context Manager, that was borrowed from some of the examples that Dennis Baldwin has in the GitHub project. So I didn't make that one up. And here we're going to keep listening for commands. And in fact, there's no way to break out of this loop really unless we send it emergency, which is what you see down here as an else if emergency clause, or else if we just hit Control C. That will break out of the Python code. And then now we're actually getting socket received data from the EEK. And so we've got this sock object, and we have a size limitation on the data that's received. And then we want to make sure that when we get data coming in, we rip out any non-printable characters and null characters so that it doesn't screw up the string processing. And if we're sending an _v command from the EEK, then that means we're using gamepad controls and we're not, we're doing distance commands. So those are like the RC commands that we get from the gamepad controller to the real tello. And then we're using the syntax of kind of tello. So takeoff, land, up, down, forward. We're not really paying attention to any distance values. And then we're using the default distance. When we call on the commands, which are part of the simulator, DroneBlocks Simulator API. So drone.anything is a command that the simulator understands. So drone.takeoff, drone.land, fly up, fly down, fly forward, fly back, fly right, fly left, yaw right, yaw left. I've even put the flip command in here because the simulator does do flips, although I don't try to delineate between forward, backward, sideways flips. It's just going to always be flip backward. And then if go commands come in, then the way I translate those is I use the simulator command fly to XYZ. And so there is data coming in from the EEK, and you can go back and examine the EEK code to see what the commands look like when they're coming in. And then there's also the ability to do curve. And in fact, one of the canned flight methods actually invokes the fly curve command in order to do kind of a more advanced kind of drone simulation where a circular kind of flight behavior is detected. So that's the main, it's in the end, it's really quite simple. I'm just getting data through a socket. The data is text. And then based on the data that I'm receiving through the socket, then I set up to call the drone behaviors that are part of the DroneBlocks simulator. And then the main method is we set up the socket, we bind to the chosen UDP IP, UDP port. We print a little status message that we're listening. You have to put your SIM key here in order for this to work, and you have to be looking at the DroneBlocks simulator in a browser tab. But if you've done that, if that's a valid key, then calling the move with controller command and using your EEK, you can actually cause the DroneBlocks simulator to fly. And I believe I have a demo video of that as one of the video resources. So let me shut this particular walkthrough video down now.